Good morning, student. Today, another important aspect of current electricity will be discussed, and that is the resistivity and various other terms like conductance, conductivity, the application of it in our daily life. Student, the term resistance. From Ohm's law, we have learned a formula that V is equal to IR and V upon I is equal to R. So remember, students, V upon I is not a description of resistance. It is only a method to measure resistance. And basic the resistance, what it means is, it is when a charge carrier flows in a conductor or in any substance, there are certain obstacles which comes in the path. These obstacles which comes in the path in a material is termed as resistance. So mostly now we are talking about resistance of the, say, any substance, any sample, and we are taking different length, different area of that sample. And as you already studied in your lower class, this resistance depends basically on length, area of cross section, and the nature of the material. The term is resistivity, student. So R is equal to rho L by A, already you know it. Just have a deeper look into this formula. R is equal to rho L by A. Student, if I make A is equal to 1 and L is equal to 1, this formula becomes rho is equal to R. Rho means that is a resistivity, student. Specific resistance. Okay. Now, student, actually what this means, rho is equal to R. You see the previous formula, V upon I is equal to ml upon N square tau A. When I am making L and A 1, student, I am repeating it. When I am making L and A both are 1, see the other quantities which are there. One is m, mass of the electron, that cannot be changed. E, charge of the electron, which is not changeable. Tau is the relaxation time. If temperature is constant, it is also not changed. So only one quantity is left, which small letter n, that is density of the charge carriers. So if the sample is not changed, this n will also not changed. This means, student, the quantity which I am saying rho, it will change only due to change in material. When I change the material, the small n will change. So that means A is equal to 1, L is equal to 1 means if you take any substance or any conductor whose area of cross section is 1 and length is also 1, then the resistance which comes across its faces is measured to its resistivity. So remember, student, resistivity is a property, it is the nature of the material. Only when I will change the material, the sample, then the resistivity will change. Otherwise, in the same sample, resistivity will not change, even if I changes the length, area, and other quantities. So resistivity is a property of the student material. And now we have another formula for resistivity. You can see I have written it, m upon n e square tau. So these are the factors on which resistivity will depend. Mass, which is a constant, E also constant, tau at constant time constants. It is only the n, small letter n, student, which will decide the value of resistivity, and small n will change only when we change the substance. So got it, student? Resistance and resistivity. Resistance is the property of obstruction, and the main cause behind resistance, say in case of conductor, it is collision, student. Remember, collision is the main cause, and the obstacle which is coming due to collision is termed as, student, resistance. Here I have also written the unit of resistance, 1 ohm. This you already studied in class 10. Unit of resistivity, ohm meter. You already knowing the meaning of 1 ohm, so no need to describe it again, student. So here I have written the definition also of resistance, student. Here I am trying to show one circuit here from a power supply to your home. I have shown a big wire of a large length, and I have shown a generator. Have you noticed, student, in both the case, in our a bulb and the generator case, there is a earthing is there. If you enter a powerhouse, you will see there is a earthing. In our home also earthing is there. I have written one word, student, if you can see on the screen, speed of impulse. And I have written it 3 into 10 is to 8 meter per second, student. Try to understand the meaning of this. Whenever the generator or the power station makes the switch on, it produces an impulse, and this impulse travels with the speed of light. The electrons are scattered throughout the wire. So remember, student, the electron which is there in the power station, that electron does not have to travel to our home to make the to make the bulb light, or to light our bulb. Already electrons are present, only the impulse comes, and the electrons which are already present, they start moving in a particular direction, and those electrons which are already there before near the bulb, they start entering the bulb, and they collide, and due to that collision a heat is generated, and that you see the light. So have you understood the word, student, the meaning of impulse? This is the force or the impulse which travels at a speed of light as soon as the power is on. So the one question which comes is, though the drift velocity is very small, then how it happens that whenever the switch is on, at the instant the bulb is lighted? So have you understood the concept behind it, student? Electron does not have to travel such a large distance. It is the impulse which travels, it is the disturbance which travels and forces the electrons to move in a particular direction. And thus the light becomes on as soon as the power is on. Suppose the wire which is coming to your home, student, due to the say heavy wind or something, the wire in the mid part of the wire that touches the ground. So now what happened is, the bulb of your house does not glow. The current returns from that touched part of the ground, and that is known as short circuit. Current means that circuit becomes short. We will talk it in detail later on. Now student, the resistance, when you say a substance has a higher resistance, we say it is a better insulator. When you say the resistance is very less, we say it is a conductor. We don't say in terms of resistance, we don't say in terms of property. Now students, see, insulator means what? Insulator means a very high resistance. Where it is needed, student, if you see the wire which are coming to our home, in between there are light poles, because the mechanical support is required, because the such a long wire, if it is not supported, it will be broken by the heavy wind. Now the light pole which are connected to the wire, the current should not flow in that pole to the ground. There in student, you must have seen a big stones are hanging sometime, that is insulators. Insulator does not allow the current to enter into the pole. Why? Because it is a very high resistance. So can you see the importance of insulator, student? How much it is important to have a high resistance? Now the inverse of resistance, the substance which have less resistance will be a good conductor. So the term is conductance. So what is conductance? It is a property of conductor, student. So I have denoted it by symbol sigma, 1 upon rho. This is one relation between conductance and, sorry student, sigma, it is conductivity. I told you conductance is capital G, okay? Capital G is 1 by R, and sigma is 1 upon rho, resistivity, that is. And remember, they are the property of the material. Now student, let's talk about the unit of conductance. It is mho, or it is given another name, Simon, written ohm per ohm. Unit of conductivity per ohm per meter. Already you know the unit of resistivity, student. Now student, let's have a miniature form of Ohm's law, microscopic form. We already know I is equal to V by R. There is a one quantity, student, current density. And what it means? Current flowing per unit area. Current flowing per unit area. And it is a vector quantity. So see, I have written I in terms of J into A. J is current density. Now student, V, potential difference, that can be written in the form of E into L. Potential V is a bigger form, but E, electric field, it is applied to each and every part of the conductor, every particles of the conductor. So it is a miniature form, small form is E. That is why I have to multiply E with L, then I am getting V, student. R I have written in the form of rho L upon A. So here I have got one more formula, J is equal to E upon rho. And as just now I told you, 1 by rho resistivity is sigma. So J is equal to sigma E. This is another form of Ohm's law, student. A vector form, microscopic form, or miniature form, you can say it. J current density, sigma is the uh, conductivity, and E is the electric field, student. The miniature form of Ohm's law. Now student, about the properties of resistance. Let's talk about one numerical part of it. Suppose, student, if we have a wire of resistance R and it is stretched to double its length. Now see student, we listen very carefully. A wire of resistance R is stretched to double its length. Note the quantity which are changing, student, quantity which are changing. The material is same, the same wire is stretched. So the resistivity will not change. This is the first factor you have to note. Second thing, the wire is still the same. The volume, we are not adding anything. Volume will also remain the same. Now the quantity which changes are L and A. And remember student, L and A are the property of the sample. So which quantity will not change? Volume. And which quantity will change? L and A. L is already given, A is you have to find out. And material will also not change. So from here volume will not change. So I have written the formula A1 L1. It is before stretching, A2 L2 after stretching. So I have got the ratio A1 upon A2, L2 upon L1. Now student, the formula resistance before stretching, rho L1 upon A1, R2 rho L2 upon A2. Then I have divided the mathematical form and I got a formula R2 upon R1, L2 upon L1, A1 upon A2. Now student, according to given condition, L2 is twice L1, you can see it, I have written it. Now if L2 is twice L1, student, and the volume L2 upon L1 is 2, here see, then you see from the volume relation how much is A1 upon A2, student. A1 upon A2 will be 2, student. So A2 will be A1 upon 2. Now you see this formula R2 upon R1. I have written L2 upon L1 into A1 upon A2. Now from the relation you can see, student, L2 upon L1 is same as A1 upon A2. So I have written it. So I got a formula R2 upon R1 as A1 square upon A2 square. And then I have substituted it and I got the answer 4. So means here, student, you have to note it one thing. I have got R2 is equal to 4R1. Means when I am stretching the wire to double its length, it is the resistance is increased by 4 times. Okay student, see the method once again. The volume is same, resistivity remains same. Then I applied the formula and ultimately I got the formula A1 square by A2 square is R2 upon R1. Let's student generalize the formula. Let's see, which will help to save time in the competitive exam, student. See student, length increases n times, it is given. So this means A will decrease n times, student. A will decrease n times. Remember student. Now see, I have applied the formula again. R1 is equal to rho L by A. This is before stretching. Okay. R2 rho L. L becomes n times NL I have written. A becomes A decreases. I have written A by N. Now see student. The R2 I am getting N square rho L by A. Now what is rho L by A, student? It is R1. Now see student, I got a general formula. R2 is equal to n square R1. R2 is equal to n square R1. And student, what is n? What is n student? It is the number of times wire is stressed. Now student, in competitive exam you don't have to solve it full. You will get the answer within a second. For example, if it is given a wire of resistance 20 ohm is stretched to 4 times its original length. A wire having resistance 20 ohm is stretched to 4 times its original length. What is the new resistance student? I think you got it. N is how much is n student? 4. So 4 square is 16. 16 into 20, 320 ohm. Any question, suppose the wire has been stretched to say 2.5 times. So 2.5 times means 5 by 2. So you make it 5 by 2 square into the original resistance which is given. If it is 20, so 5 by 2 square into 20. You will get the answer student within a second. You will get the answer student. So today student, we have discussed about the term resistance, about the term resistivity, conductance, conductivity, and their units, the miniature form of Ohm's law. Student, try to revise it in your memory and try to write it on your own words. Then we have discussed one numerical also, and we have discussed a very important general formula of it. On what factor resistance depends. And remember student, the difference between resistivity and resistance. Resistance will depend on the dimension and the material, and resistivity will depend only on the nature of the material. The resistivity can only be changed when the material has been changed. Otherwise, it will remain same if the temperature is constant. Then the numerical which we have discussed. Remember in this question the volume is not changing. We are not adding anything student. I hope you understood today's. In the future classes, more and more basic concept will be student discussed. Thank you.